Hi guys, welcome to the channel. I'm the Jacobian Dev, and in this video I'll be going through how to create a Grasshopper component using C#. I'll be using the project templates for Rhino 3D, which contain Grasshopper templates. I'll be creating a Grasshopper component for Rhino 8. To get started, back in Visual Studio, I'll continue with our code. In the Extensions tab, I'll select Manage Extensions. Under Install Extensions, I'll search for Grasshopper. The project templates for Rhino 3D is the extension that needs to be installed. As you can see, I already have it installed. I'll then create a new project. I'll search for Grasshopper. I'll select the Grasshopper assembly for Rhino 3D C# project. Next, I'll specify the project name as my first GH component. I'll save the project in the Documents folder. I'll then proceed to create the project. The project will target Rhino 8, and I won't check the option to build a Yak package. A Yak package is a Grasshopper plugin package that you can share with other users. It bundles the compiled components and any dependencies, so you can install and test the plugin easily. I'll click Finish to finish setting up the project. Now that the project has been created, Visual Studio gives us a default class. Next, we'll go through it step by step to understand what's happening. This class is called firstGHComponent and it inherits from GHComponent. That's the base class that all custom Grasshopper components must extend. It gives us the structure and the methods we need to define inputs, outputs, and the actual logic of our component. At the top, you'll see some using statements. These bring in namespaces from Rhino and Grasshopper, like Rhino Geometry for geometry types and Grasshopper Kernel for working with the Grasshopper API. The constructor is the first important part. Here we define how the component will look inside Grasshopper. The name is what shows up when you hover over the component. The nickname is a shorter label that appears on the component itself. The description explains what the component does. And lastly, the category and subcategory decide where the component lives in the Grasshopper tabs and panels. Then we have three key override methods. Register input params. This is where we define the inputs for the component, for example, numbers, curves, or points that a user can plug into the component. Register output params. Here we define the outputs that Grasshopper will return after the component runs. And the solve instance method. This is the most important method. This is the code that takes the input data, processes it, and assigns values to the outputs. Below that, we have the icon property. Every Grasshopper component needs a 24 by 24 pixel icon to show in the UI. For now, it's set to null, so the component will just show up with a default placeholder icon. And finally, there's the component GUID. This is a unique identifier that Grasshopper uses internally. Next, back in the constructor, I'll update the name and add the nickname as first GH component. I'll set the description as my first Grasshopper component. I'll set the category to Jacobian Dev and the subcategory to examples. Next, inside the register input params, I'll add the first input, which will be a number parameter. There are other input options to choose from. I'll set the name to number, the nickname to n, and the description to input number. I'll then set the parameter access to item, since we're working with one individual item. If we were working with a list of numbers, we would select the list option, and if we were working with a tree, we would select the tree option. Next, I'll add the second input, which will be a point parameter. I'll set the name to point, the nickname to p, and the description to input point. The name is the full descriptive label for the parameter. It's shown in tooltips when you hover over the input or output on the component. The nickname is the short label that actually appears next to the input-output grip on the component itself. Next, inside the register output params, I'll add a number output parameter named doubled. I'll set the nickname as 2n and the description to input number multiplied by 2. I'll then set the parameter access to item. This should output the input number multiplied by 2. Next, I'll add a point output parameter named moved point. I'll set the nickname as mp. and the description to point moved by the input number. I'll also set the parameter access to item. Next, I'll take a look at the solve instance method. This is where the logic happens. First, I'll declare a number variable to store the number input. I'll also declare a point variable. Next, I'll get the input data for the number input by calling the getData function, passing 0 as the index and referencing the number variable as the second parameter. I'll then get the input data for the point input. I'll declare a new doubled variable by multiplying the number by 2. I'll then declare a moved point variable that moves the point input. Lastly, I'll set the output data by calling the setData function. Now to add the icon, in the properties, I'll add a new resource file called resources. I'll then open the file using the Manage Resource Editor. I'll then add an existing resource. I'll navigate to my Documents folder. I'll then add the Jacobian icon image. Back in the first GH component class, I'll reference the icon image by calling the properties resources. Once that's done, I'll go ahead and run the project. In Grasshopper, in the Jacobian Dev tab, we can find the first GH component. The component provides a warning that the input parameters are not provided. I'll add a number slider with the value of 25. Back in Rhino, I'll add a point. I'll then collect the point in Grasshopper. I'll then connect the point as an input. Once the component is ran, we can then check the results by connecting a panel to view the outputs. That should be it for this video. If you have any questions, please leave them in the comment section below. Also, don't forget to like, share, and subscribe.